All right, let's jump right into this explainer. Today, we're tracking down a real performance-killing villain in modern web development, bundle bloat. If you've ever watched your web app get slower and heavier with every single feature and dependency you add, well, you're definitely not alone. We're going to figure out how to trim that fat and absolutely master the art of dead code elimination. Picture this. You ship a 450 kilobyte utility library. You're thinking, hey, modern browsers, 5G, they'll handle it just fine. But then you simulate a 3G connection, and ouch. It takes 4 agonizing seconds just to download. And the absolute worst part? You look at your performance profile and realize that 60% of that massive download is completely unused, dead code. You're literally making your users wait for code your application doesn't even need. Look, this bloat isn't just some abstract metric we can ignore. It is actively ruining your user experience. Every single kilobyte of JavaScript has to be downloaded, parsed, and compiled before the page even thinks about being interactive. That totally tanks your initial load times and it crushes your core web vitals, especially largest contentful paint and interaction to next paint, which directly hurts your search rankings. Plus, all that parsed code just sits there hogging memory, causing garbage collection pauses, making everything feel super sluggish, especially on mobile devices. So how do we fix it? We need the ultimate dead code detectives tool.
Section 1. What exactly is tree shaking? Okay, think of your app's dependency graph like an actual physical tree. Your source code and all those libraries you import, those are the branches and the leaves. Tree shaking is a process that happens during your build step, using bundlers like Webpack or Rollup, where it basically grabs the trunk of this tree and vigorously shakes it. The whole goal is to make sure every single dead, unused leaf falls off, leaving absolutely only the essential living branches behind for your final production bundle. But there's a catch. This only works if you, the developer, leave the right clues. Which brings us to Section 2, the core conflict, ESM versus CommonJS. So the fundamental difference here is how the bundler actually reads your code. ES modules, or ESM, create a super predictable static dependency graph. Because those import and export statements have to sit right at the top level of your file, a bundler can look at it and know exactly what's being used at fill time without ever having to run the code. CommonJS, though, it uses require calls, and those evaluate dynamically at runtime. Because you could hide a require inside an if statement or deep in a nested function, the bundler cannot confidently predict what you'll use. So it plays it safe, blocks dead code elimination entirely, and just includes the whole thing. This really highlights the problem, and Moment.js is our prime suspect here. Since it relies on CommonJS and heavily bundles its internal modules, importing just one tiny date formatting function pulls in the entire 67 kilobyte library. Compare that to a modern alternative like datefns. It uses ESM and named exports, which lets you shake away the excess and bundle only the exact functions you call. And looking ahead, the temporal API, which is being built right into modern JavaScript, gives you a literal 0 kilobyte footprint because it's native to the language. But spoiler alert, just using ES modules isn't a magic fix on its own. Let's dig into Section 3, the side effects trap. Here is the absolute most crucial thing to remember. Tree shaking is a highly defensive process. Your bundler's main job is to make sure your app doesn't break when it goes live. If you give it any ambiguous signals about whether a chunk of code does something important, it has no choice. It's going to panic and bundle absolutely everything. It needs undeniable proof that the code is unused. Check out this super common anti-pattern. If you use a namespace import, import star as utils, and then pass that entire utils object into a console log or some higher order function, you've just completely wrecked the bundler's static analysis. At build time, it has no way to prove which specific properties of that object might get accessed dynamically later on. So it keeps every single export, even the 7 functions you didn't actually need, just in case. Switch to named imports, like import reset pagination. It gives the bundler a crystal clear signal of what you're actually using. You've also got to actively help your bundlers out by using the side effects flag in your package.json. A side effect is basically code that executes just by being imported, like a file that secretly injects CSS styles into the DOM or a polyfill that tweaks the global window object. By explicitly setting side effects to false, you're promising the bundler that your code doesn't pull any of those sneaky tricks. That gives it the green light to aggressively drop those unused modules. And you might have occasionally noticed those pure comments scattered around modern JS source code. While the JavaScript engine just sees a standard comment, it's actually a powerful secret handshake for minifiers like Cursor.
These pure function annotations explicitly promise the minifier that a specific function just computes and returns a value, no hidden network requests, no DOM mutations. Meaning, if that function's return value ends up being ignored, the minifier knows it can safely delete the whole function call from the final build entirely. Pretty cool, right?
All right, Section 4, Tools and Best Practices. Let's get you set up to be a real dead code detective. You simply cannot fix what you aren't measuring. Making a habit of using visual measurement tools is absolutely non-negotiable. Tools like Webpack Bundle Analyzer or the Rollup Plugin Visualizer generate these massive, interactive, colorful tree maps of your build output. You can literally click into a package and see exactly which internal modules are hogging all your space. And before you even type npm install to add a dependency, go check it on Bundlephobia. It'll tell you its download time on a 3G network and, most importantly, whether it even supports tree shaking in the first place.
But hey, we're human. We forget to check visualizations. For a really robust automated defense, you've got to set up size limit in your continuous integration pipeline. This tool calculates the real-world bundle cost of your code. If a teammate opens a pull request that accidentally pulls in some massive untree-shakeable library that blows past your strict budget threshold, the CI pipeline just automatically rejects the build. It is an incredibly effective safety net.
Now, if you're authoring libraries for other devs to consume, you've got a real responsibility here. You must publish pure ESM native packages using named exports. You absolutely need to configure that side effects flag properly. Avoid barrel exports, the files that just re-export everything from a directory, if they bundle any side effects. And please, always use peer dependencies for massive frameworks like React or Vue so you don't accidentally force your users to download duplicate copies of those frameworks.
Tree shaking is a seriously powerful tool, but it definitely isn't magic. It requires your active cooperation, a real shift towards static analysis, and just being hyper-aware of what dependencies you're inviting into your codebase. So before you deploy that next release, I want you to take a hard look at your dependency graph. Ask yourself, what is actually running to provide value to your users, and what is just dead weight coming along for the ride? How much dead code are you shipping right now?